Hello again, guys. Earth, our home. The only planet we know that harbors life. But even this haven has an expiration date. And the cause? The very star that gave us life, the Sun. For 4.6 billion years, the Sun has fueled our world, providing the energy for everything from ocean currents to photosynthesis. Every single second, it converts around 600 million tons of hydrogen into helium, releasing immense amounts of energy. But this fuel won't last forever. One day, the Sun will run out of hydrogen. And when that day comes, it won't go quietly. Right now, the Sun is in its stable middle age, what astronomers call the main sequence phase. This period lasts about 10 billion years, and we're roughly halfway through it. But even in this stability, change is slowly unfolding. As more helium builds up in the Sun's core, the core compresses and the outer layers expand slightly, increasing the overall brightness. In about 1 billion years, the Sun's brightness will increase by around 10%. That small change will have massive consequences. Carbon dioxide levels on Earth will fall. Plants will struggle to survive. And without plants, the entire food chain begins to collapse. Photosynthesis, the process that supports nearly all life, will come to a halt. At the same time, surface temperatures will rise. Oceans will begin to evaporate. Water vapor, a powerful greenhouse gas, will trap even more heat, pushing Earth into a runaway greenhouse effect, similar to what we see on Venus today. Eventually, the oceans will disappear completely. Without oceans, Earth's tectonic plates may stop moving. That means no earthquakes, no volcanic activity, and no magnetic field generated by the Earth's core. Without that magnetic field, solar radiation from the Sun will strip away our atmosphere, exposing the planet to deadly cosmic rays. Fast forward 5 billion years. The Sun's core runs out of hydrogen, and fusion grinds to a halt. Gravity takes over. The core contracts and heats up, and the outer layers swell. The Sun becomes a red giant, expanding to hundreds of times its current size. Mercury and Venus will be consumed by the Sun's expanding outer shell. Earth? Its fate is uncertain. Some scientists believe that our planet's orbit may expand outward, just enough to escape total engulfment. But even if we avoid being swallowed, the results will be catastrophic. The heat will be so intense, Earth's surface may reach thousands of degrees Celsius. Our atmosphere, long gone. Our oceans, vaporized. The crust, liquefied. Then comes the final act. The red giant will lose its outer layers, casting them off into space and creating a breathtaking planetary nebula. What remains is the Sun's core, a white dwarf. No larger than Earth, but with half the mass of the original star. It will slowly cool for trillions of years, radiating faint light into the void. And Earth? If it hasn't been consumed, it will remain, an icy, lifeless rock orbiting a fading white dwarf in eternal darkness. This isn't science fiction. Astronomers have observed white dwarfs surrounded by the debris of destroyed planets. Our telescopes, like Hubble and James Webb, have revealed the death throes of solar systems. This fate is written in the stars. But there is hope. Long before the Sun begins its death spiral, humanity may find a way to escape. We could colonize Mars, build space habitats, or travel to distant star systems. Our survival depends on how far we're willing to go, and how fast we can get there. The Sun gave us life. One day, it will take it away. But if we dream big, explore far, and act wisely, Earth's story doesn't have to end here.